Ja, guten Tag, liebe Freunde von 4P Solutions. Herzlich willkommen auf unserem Kanal. Bei uns dreht sich alles rund um die Themen Klima und Energie. Und unser Anspruch ist es, diese Themen faktenbasiert, ideologiefrei und mit globalem Blick zu behandeln. Wenn Ihnen unsere Inhalte gefallen, abonnieren Sie doch gerne unseren Kanal, aktivieren Sie die Glocke und geben Sie uns ein Like. Hinterlassen Sie auch gerne einen Kommentar. Darüber hinaus können Sie sich an unserem Verein beteiligen, entweder aktiv als Mitglied oder durch eine Spende. Als Mitglied können Sie aktiv an Projekten teilnehmen, erhalten Zugang zu unserer App und können direkt an Diskussionen mit unseren Referenten auch teilnehmen. Jede Unterstützung hilft uns und Sie auch weiterhin mit spannenden Vorträgen und fundierten Informationen zu versorgen. Wir wünschen viel Spaß bei dem Video.
Dear friends of 4P Solutions, today we have the great pleasure of having an English-speaking presentation by Roger Pielke Jr. Roger Pielke Jr. is an American scholar and writer whose work sits at the intersection of science, technology, and public policy. And he focuses on climate, energy policy, disaster risk, and the governance of complex institutions. He spent many years on the faculty of University of Colorado Boulder, and he has held research roles early on in his career at the National Center for Atmospheric Research. He has been associated with Corporate Institute for Research and Environmental Sciences, CIRES, one of the leading US institutes for environmental studies, researching climate change, weather phenomenon, ocean and earth systems. He has been emeritus since the end of 2024, and he is the author of influential books and on the role of science and democratic decision-making. And he also runs a podcast called The Honest Broker and the Climate Fix. Yeah, Roger, just recently, Heinz Otto and we attended a social event in Bremen, Germany, where the CEO of Munich Re, global reinsurance company, Dr. Joachim Wenning, delivered a speech on global risks and global risk management. And during the break, Wenning and I were standing next to each other in the toilet. And I took the opportunity to ask him about the relation of natural catastrophe costs and climate change. And while we were standing next to each other, he responded to me that it would be too much of a complex issue to be discussed in this environment, meaning on the toilet. Therefore, ever since then, I've been looking very much forward to have this evening with you and to learn more about these complex topics, and we are very much forward to your presentation. And Roger, the stage is yours.
Thank you, Axel, and hello, everyone. It's great to be with you. Just to let you know, I've spent many days and weeks in Germany, one of my favorite countries, in Hamburg, Leipzig, Friedrichshafen, Munich. I had occasion to be on several advisory panels in Hamburg for climate research, which brought me there every year, and was able to attend St. Pauli football matches, so that was always great. All right, so I have my slides. It's basically a conversation starter. This is not a research presentation, although I'm happy to go into as much detail about our research as anyone would like. But I introduced these topics mainly to put some assertions, some arguments, some data on the table to allow us to have a more informed discussion. My sense is that our discussion will be far more interesting than my presentation, so I'm going to get through my slides, and I title it 10 perhaps surprising facts, because one thing that I've noticed in the last couple years is that the climate conversation has changed dramatically. Everything I present to you today, in the last few years, some people in some audiences would get red in the face and very upset about presenting them. And today I'm not so sure. There's a lot of pragmatism, common sense that has broken out in the climate discussion. Not everywhere, of course, but you'll have to let me know if there's anything surprising in this presentation. So with that, I'm going to jump right into it. All right, so the first one, and to echo something that Axel said, climate change is real and it poses risks about the future. And one of the, I guess, fundamental aspects of climate science is inherent uncertainty, where we don't know what the future has in store for us, but also ignorance. Ignorance is we don't know what we don't know. The graph I show here is of ocean heat content. There's a lot of debate and discussion over global surface temperature trends. I've been convinced by many, including by my father, who's an expert on this, that the place to look for the human signature of influences on climate in the first instance is the global oceans, which are a much larger reservoir of heat than the atmosphere. And there the signal is undeniable. Since about 2000, the Argo float system has allowed for reliable measurements of ocean heat content. And indeed, it is going up, and it is associated with the accumulation of greenhouse gases. Of course, climate change is much more than just greenhouse gases. There are many other human and non-human influences. And one of the things, and we could talk about this, one of the things that I think goes underappreciated in the discussion of climate is the long-term historical variability of the climate. You'll often hear that the goal of climate policy is to return to the temperatures of the time period 1850 to 1900. One, I guess, benefit of using that as a policy goal is that most people have no idea what the climate was back in that era. Turns out that the 1870s were one of the most intense eras for extreme weather events. The 1877-78 El Nino event was massive and caused worldwide climate disruption. And by some estimates, 4% of the global population died in the 1870s due to extreme climate events. All right. So just because climate change is real doesn't mean that every assertion that's made in the name of climate change is accurate. So my second point, after decades of warming, most types of extreme weather still show little or no detectable long-term change. And what I tell people is, you don't have to believe me. This is straight out of the Intergovernmental Panel on Climate Change, Working Group 1. And I have been critical of the IPCC at times, and its Working Group 2 certainly deserves it. Working Group 3 is captured by a very narrow set of scholars in the integrated assessment modeling world. For the most part, in my areas of expertise, Working Group 1 has called things straight, at least as in terms of how I read the literature. So what I'll do is I'll just briefly talk a little bit about what the IPCC concludes on the detection and attribution of changes in extreme weather events. And just a terminology aside, detection, I'm sure most of you know this, but detection refers to the identification of a change in a particular variable that's outside the range of historical variability. The IPCC says they wish to be 90% certain before making such a claim that a change has been detected. Attribution is the process of identifying why that change may have occurred. So this is taken from a figure table in the IPCC, and you can look it up yourself. It's table 12.12 in the report. I have reformatted it so that it's easier for people to read. And what the IPCC did with this table is they identified where the signal of climate change has emerged from the background of natural variability. And they call this, there's a technical term for it, they call this the time of emergence. And they also ask, given model projections, do we expect the signal to emerge by 2050 or 2100? And both of those projections are under the most extreme climate scenario, which I'll talk about in a moment. But I guess what many people are surprised to learn, and this is why your conversation, Axel, with the head of Munich Re would have taken longer than a toilet break. The signal hasn't emerged for most phenomena yet. And then if you look at when the IPCC projects the time of emergence to occur, there's a lot of white space in that graph, which means that even under the most extreme scenario, that signal is not projected to emerge by 2050 or 2100. This makes it very difficult scientifically to try to use extreme events as the basis for arguing for climate policies. That hasn't stopped people, and it hasn't stopped the emergence of a side industry called extreme weather attribution, which we could talk about, that tries to make such connections. But the IPCC has called things straight. And really, if you take a look at the mathematics of extreme events, one of the worst places to look for changes in climate due to human influence is extreme events. And I'll just give you an example. There are only something like 80 tropical cyclones of hurricane strength every year on planet Earth. 80 is a very small number, and it's very difficult in a noisy time series to detect a change in the statistics of such a small number of events. One reason why, you can see here, temperature extremes and precipitation extremes, it is easier to detect signals because we have so many detailed measurements of precipitation and temperature all around the world. So extreme events are not the best place to look for changes in climate, even though they're the most photogenic and often used in advocacy. So here's just one example, US hurricanes, so if you're Munich Reinsurance, you care about US hurricanes because it's about 60% of insured property losses worldwide. So it's a big deal, largely because of the massive amount of coastal wealth in the United States. But every time there's a hurricane, it's singled out as the manifestation of human-caused climate change. And this is very popular in the media, and it's very popular in advocacy. I have studied hurricanes since the 1990s. Started studying hurricanes before they were a climate issue. But the top graph here shows continental US landfalling hurricanes from 1900. There's no trend in that time series. And the bottom is the major hurricanes. The major hurricanes are what are called Category 3 and stronger. They're responsible for about 85% of damage. So they're the big ones. And again, there's no evidence of an increasing trend in those events. Landfalling US hurricanes are just a small portion of global hurricanes. And so this is a measure of tropical cyclone frequency and intensity. It integrates those two measures. This is from 1980 to 2024 from Phil Klotzbach at Colorado State University. And this is total ACE, accumulated cyclone energy, over this period. And again, there's a lot of ups and downs and no trend. I'm not showing the data here, but if you look at ACE per hurricane, there's also no trend in the strength per storm, contrary to a lot of popular claims. The US government agency, NOAA, has an updated assessment of tropical cyclones, and they state it's premature to conclude with high confidence that human-caused increases in greenhouse gases have caused a change in past Atlantic basin hurricane activity that is outside the range of natural variability. That same conclusion holds globally also, but it is during hurricane season, it is a weekly battle with the media, which makes all sorts of claims that are certainly not supported by the scientific evidence. This gets more towards the bigger picture. These are global weather losses as recorded by Munich Reinsurance as a proportion of global GDP. Global GDP data comes from the World Bank. This is updated from a 2019 paper I did. There's no increase since 1990. It starts in 1990 because that's when Munich Reinsurance says their data is reliable, and so I trust them on that. Since 1990, there's absolutely no increase. And there's good reason for that. The world pays attention to disasters. And one of the greatest success stories of science, technology, and policy has been the world's ability to adapt to extreme events, both in terms of economic losses and in terms of loss of life and displacement. I take this data here and I map it onto the projection of the Stern Review. So if you followed climate policy discussions for a long time, this goes back to 2006, the Stern Review was a very influential British government report on climate change that basically argued that climate change was going to be apocalyptic and that really no cost should be spared in responding to it. And there's a long story here. The Stern Review used a paper that I had commissioned for a workshop that we held outside of Munich with Munich Reinsurance, and they misused it to project these gray bars, which was an ever escalating and accelerating escalation in disaster losses as a proportion of GDP. The black bars are what has actually happened since they made that projection. There has been no trend. And so looking back, and for better or worse, I wrote a peer-reviewed paper that explained why the Stern Review was wrong on this topic at the time, which was mostly ignored. But again, extreme weather events and their impacts are not a particularly useful place to look for signals of human-caused climate change. This is a remarkable statistic that most people are unaware of, but the success that the planet collectively, humans on planet Earth, have had in reducing the human impact of extreme weather is just mind-boggling. So again, I mentioned the 1870s. The estimates are, again, order of magnitude, 50 million people died around the world due to extreme weather events. And in the 2020s, it will be closer to 50,000. So 3 orders of magnitude reduction, even as population has increased dramatically. This even from the 1970s, an order of magnitude reduction. Here's some numbers, just to put some numbers on in terms of death rate. In 1960, 320 people per million on planet Earth died from extreme weather. In 2025, it was less than 1. And again, this is a great indication of progress. Can it continue? Only with concerted effort. We don't get this for free. It's not magic. It's because there's a lot of attention paid to improving outcomes by reducing vulnerability, reducing exposure. One of the greatest success stories over this time period is in the Indian Ocean basin, in places like Myanmar, Bangladesh, India, where in the 1960s it was routine for tens of thousands of people to die every single year from tropical cyclones. And today there's good warnings, there's good evacuations. Still many people die, in the hundreds often, and it was only 2008 when there was a massive loss of life, tens of thousands. But this progress can continue. All right, climate risk and extreme event attribution are narrative concepts, not scientific. Climate risk is a concept that emerged in the finance industry. The idea that there was some layer of risk that had gone unnoticed, say by the insurance industry or catastrophe modelers, that threatened the global financial system. And I mentioned extreme event attribution, which is focused on taking a particular event and claiming that it was 40%, 150%, 200% more likely because of human-caused climate change. If you look at the long history of science, economics, and policy, there are some uncomfortable statements that were made. This is Tom Schelling, who won the Nobel Prize. This is in 2009. It's a tough sell. You probably have to find ways to exaggerate the threat. Part of me sympathizes with the case for disingenuousness. I sometimes wish we could have over the next 5 or 10 years a lot of horrid things happening, like tornadoes in the US Midwest and so forth. That would get people very concerned about climate change. Unfortunately, that's not an old perspective. This is the New York Times just recently, a few years ago. climate scientists and environmentalists hold out hope that each new hurricane and hailstorm could nudge Americans towards action. The climate advocacy community has placed itself in a very awkward position in cheering for, hoping for disasters so that they can claim that they are associated with greenhouse gases to try to motivate changes in energy policies. Most recently, particularly in the United States, but not limited to the United States, there is this argument that climate change is leading to higher homeowner insurance bills for individuals. And the reality is this is the profitability of the property casualty insurance industry. And you can see this 2023 and 2024 had very large profits for the industry, partly because of concern about climate change has boosted rates. 2025 is another incredibly profitable year. Munich Reinsurance, to give another example, at the global level, reported profits of over 6 billion euro, and they expect that to go up to 6.5 billion euro in 2026. They're doing quite well. This is the underwriting profit or loss from underwriting insurance. There's no trend in these numbers. The insurance industry seeks to break even on underwriting, and they make their money based on investments on the money that they hold from people. So again, there's no sign that the climate crisis is becoming an insurance crisis. All right, number 5. So this is probably the most important thing I'll share with you today. I have always called this over the last 5 or 10 years the best kept secret in all of climate science. It's less of a secret today, but it's still not as widely appreciated as it should be. Climate researchers project changes to future climate based on scenarios of the future. And the reason that they use scenarios is that we do not know and we cannot predict how big the economy is going to be, global population with accuracy, the energy consumption patterns of the future, and the energy production patterns of the future. So the community uses a wide range of scenarios. This spaghetti diagram I show here shows historical emissions in the black, and then it shows about 1,200 different scenarios of how emissions from carbon dioxide consumption of fossil fuels may evolve in the future. Obviously, you cannot do research on 1,200 scenarios. So about 20 years ago, the climate community decided to settle on 4 different scenarios. They had a high scenario, that's the RCP 8.5, a low scenario, the RCP 2.6. Then they decided, well, we need 2 in the middle so that people don't focus on any one in particular. And so the RCPs have come to dominate climate research really for the last several decades. The most commonly used scenario, and I'll talk about this a bit, is RCP 8.5. So what I and a couple colleagues, Justin Ritchie and Matt Burgess, what we did a few years ago is we took those 1,200 scenarios and we graphed them here in terms of cumulative fossil fuel emissions over the 21st century and temperature change. And you can see there's more or less a linear relationship between fossil fuel emissions and projected temperature change. We drew this red oval around that because at the time, the IPCC said they were all plausible futures. These were all futures that could occur. So we just took them at their word. So 2005 is by now a long time ago. So what we said is we wanted to evaluate which scenarios survived the test of reality up until, this is 2022, because we had real world data on population, on emissions themselves, on trends in energy intensity and trends in carbon intensity of energy. And we decided to evaluate which scenarios were still in play almost 20 years later. And we also used the short-term outlooks of the IEA, International Energy Agency, and other majors out to 2040 and 2050. And so this is what happened when we applied that test to see what scenarios were still plausible in 2022. And that's the bottom graph here. And what you see is that the red oval of plausible scenarios shrunk dramatically. Our paper was titled Plausible Scenarios Are Between 2 and 3 degrees Celsius for 2100. I am happy to say we were among the very first to publish the fact that the current view on scenarios was below 3 degrees. That is now conventional wisdom. The UN Framework Convention on Climate Change just last December in Brazil argued that the world was headed for 2.4 degrees. Our paper had our median is 2.2. So we can quibble about where it is, but the very extreme scenarios at the top of the range are off the table. And I think that's a broadly shared consensus in the community. It hasn't reached the academic journals, certainly not the media, and not many in policy positions. So if we go back to the original spaghetti diagram, here's how things look today. The extreme scenarios are implausible, meaning they are already falsified. The world has moved in a different direction. And the plausible scenarios are these lower scenarios with RCP 4.5 as an upper end. We argue that the world is most consistent with a scenario called SSP 4 3.4, which no one happens to be studying worldwide. The Paris Agreement targets are at the RCP 2.6. Now, there's a few things to say about this. For a long time, the climate community argued that the world was headed towards RCP 8.5, and RCP 4.5 would be climate success. That would be climate policy success. Now, in 2026, we find that the world is undershooting RCP 4.5. So that creates a very difficult situation. How do you argue that the success story from 10 years ago is the worst case scenario today? It makes a very difficult argument to make. The other is when you project future climates, the differences in outcomes for whatever you might care about, agriculture, extreme weather, sea level rise, between RCP 2.6 and RCP 4.5, if we take that as the range of plausibility, the outcomes are very difficult, if not impossible, to distinguish in climate model output. There's a substantial overlap. That's very different than comparing an RCP 2.6 to an RCP 8.5. What that means is that arguing that there are apocalyptic outcomes in the near term based on different levels of mitigation is a very difficult argument to make based on the science. And so what we've seen among climate advocates in and outside of science is a defining down of the apocalypse. And in terms of temperature targets, it used to be, well, 4 or 5 degrees Celsius by 2100, that's the apocalypse. More recently, it's been 3 degrees, that's the apocalypse. And now even some will say, well, it's 2 degrees or 1.5 degrees, that's the apocalypse. As climate change, our perspectives on climate change have moderated, claims of apocalyptic outcomes have been inflated, almost in parallel. All right, number 6, and I'll speed up a little bit. The economy has been decarbonizing for decades. And what I mean by decarbonization is a reduction of the ratio of carbon dioxide to GDP. This is at the global level. I call this the most fascinating linear figure that I've ever seen. If you take a look, so I start this in 1992, that's when the Rio conference was kicking off the international era of climate collaboration. You take a look at this time series, there are no inflection points. If you say, well, what policies have been put in place that have altered the course of global decarbonization in the climate era? Was it the Kyoto Protocol, the Paris Agreement? Pick your favorite. The answer is none. There's no evidence that global climate policy has actually influenced decarbonization. For you guys, I threw in the graph of Germany's decarbonization, which is similarly linear. And so if you ask, well, what has the German government done with its policy, with the Energiewende, to accelerate the pace of decarbonization of the German economy, it's very hard to see any policy signals influencing decarbonization. And that's something we could talk about. I should say the United States is very similar. Not every country is linear in this fashion, but many of the industrialized countries are. So in this figure, what I did is I looked at the 8 years before the Paris Agreement in 2015 and the 8 years following, and I compared rates of decarbonization to see how they have changed. You can see for the world, this is that linear figure I showed you. There's basically no change in rates of decarbonization. Some countries have accelerated their decarbonization since Paris. A few people would pick out the United Arab Emirates as the global winner, or Brazil or Saudi Arabia. Germany has accelerated their decarbonization by about a percentage point per year. Not much change in the US, and other countries have become more reliant on carbon dioxide as a proportion of GDP. Notably China, Indonesia, they're big emitters, which contributes to the no change at the world level. But there's very little reason to believe that the Paris Agreement has led to any systematic increase in the rate of decarbonization. I don't have it shown here, but in order to hit net zero targets by, say, 2050, these values would have to be 8 to 10% globally every year going forward, starting this year. Obviously, they're not at that level. This is the United States. A figure that I showed. Do US presidents matter for US emissions reductions? US emissions have been decreasing since 2005, since the era of George W. Bush. We had a financial crisis that went off trend. We had a pandemic, but really there's no evidence that US policies or presidents have mattered in the slightest for US emissions reductions. Another big story that I think is one that we will be talking about a lot more is trends in global population. Fertility rates are just dropping pretty much everywhere around the world. And global population is going to be, I'm very confident in saying this, much below levels that were projected only a few years ago. That has a lot of implications for energy consumption, for emissions, but also the global economy. This is a figure from McKinsey, and all you need to know to understand this is that the purple or magenta colors are where population fertility is below the replacement rate. And so there's only some regions in Africa and Central Asia where population fertility rates are above the replacement level. I have a hypothesis, I'll be writing more about this in coming weeks and months, that it will not be long before countries are fighting over immigrants because they need population. So places like Germany, the United States, where immigration has been a flashpoint because of too much immigration, I would propose that it won't be long before countries are fighting over getting a reduced supply of immigrants as population projections come down. All right, getting near the end. Number 8, if you take a look at those scenarios of the future, most of them project that the poor parts of the world are going to stay relatively poor and the rich parts are going to get relatively a lot richer. So this is from a very good paper by a group of Indian scholars that looks at the scenarios of 2.0 to 2.5 degree warming in 2100 from the IPCC. And the figure shows the projected GDP per capita in these different regions. And so for sub-Saharan Africa, well, it's good news. The per capita GDP triples by 2050, but it only goes up to $9,000 US per person. In contrast, Western Europe goes from 34,000 to 51,000. The black are what are called the Annex 1 countries from the Kyoto Protocol. Basically, the rich world gets a lot richer and leaves the poor world further and further behind. So if you want one figure to explain why many in the poorer parts of the world are not fully on board with climate policy, it's this one, that climate success means keeping poor people poor. Number 9, the world's going to need vastly more energy development going forward. There are some places, Germany among them, where energy consumption has dropped. The UK is another one. But these are the exceptions. There are places around the world that are going to just be consuming massively more energy. This is from the IEA, and we could argue about its accuracy, but it projects the Japan, Korea, the EU, and North America. These are the blue parts of the bars. They're basically not going to see an increase in energy consumption, whereas the rest of the world will. The boom in AI automation has led many to believe, particularly in North America, that energy consumption will go up. But you don't need these figures. This shows projected air conditioning increases around the world. A lot of places it's hot, India in particular, and has very low penetration of air conditioning. Air conditioning consumes an awful lot of energy. This is the projections for the passenger market for airline travel, which is expected to go up, 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 up for future decades. Right now, as I give this presentation, there's 2 million people worldwide who are in a plane. Number 10, so fossil fuels are here to stay. There was a debate between the IEA and OPEC several years ago, with the IEA projecting a near-term peak in oil, natural gas, and coal. The IEA has backed off of that and is still projecting a plateauing of oil and natural gas, a big drop in coal. But fossil fuels at some level, and it's going to be significant, are going to be powering the world in 2050, regardless of what is done on climate policy. Coal consumption worldwide, China and India are the biggest consumers of coal. The EU and US are relatively small players. If the world wanted to rapidly reduce emissions of carbon dioxide, the single lowest hanging fruit is coal energy for electricity. Nuclear power is the obvious choice to replace coal. There are other alternatives as well. Natural gas is half as carbon intensive as coal and can be built at scale. I assume that the US consumption of coal will gradually be phased out for economic reasons, the same in the EU. What happens in China and India remains to be seen, but regardless, China and India are not going to get the world on an RCP 8.5 scenario. Here's the global emissions from coal. About 1/3 of the carbon dioxide emissions worldwide come from coal. Again, if the world were serious about climate policy, it would not be focused on very complicated instruments of emissions reductions, but a coal phase-out proposal, similar to what has been done already in Germany. You can see China and India dominate, and they've grown. You can see the US, South Africa, Germany, Austria, Canada, United Kingdom. They're smaller, much smaller players. Here's the long-term structural decline in the US. I think this is my last figure. This shows coal consumption in China and India since the 1970s. And 2025 was the first year that both countries saw a decrease in coal consumption from the year previously. That had some things to do with weather, unique economics. Whether that's the start of a longer term trend or not, you can see that there is a trend in declining consumption, which again is the low-hanging fruit. Here's how you can find me. I'm happy to follow up after the talk, and I look forward to our conversation together. So thank you very much.
Yeah, thank you very much, Roger. I have maybe a first question to you. The Potsdam Institute of Climate, how do you say it in English?
PIC.
PIC, you know PIC in German. It's a complicated, it's a compliment. Which relevance does it have in international climate studies, in your opinion?
PIC is hugely influential through their research, through their long-term advocacy, but also in their role in the scenario production, integrated assessment modeling. EASA in Austria is another organization that has an outsized influence. The reality is that the scientific organizations that have a tight hold on the production and promotion of scenarios are really the most influential groups worldwide on this topic.
Mhm.
There's a project. It's called the coupled model climate model intercomparison project, CMIP, that is responsible for overseeing the coordinated projection of climate futures through climate modeling. They have a subgroup that produces the scenarios that inform all of climate research, most of climate policy. There's about 15 people. I know some of the people, they're good people. There's no economists, there's no policy people. They produce these scenarios which profoundly influence how we think about, talk about, study, publish on climate change. PIC is among the select groups that get to participate in, really one of the most powerful little committees on any topic in the world.
Have you heard about the recent study from 2025, I believe? It's called the Economic Commitment of Climate Change. It basically claims 19% of income losses up till 2050, based on some studies in Uzbekistan. As far as have you heard about this study? They had to take it back in December.
Yes.
What do you think about this whole incident?
Yeah, so the incident, so the fact that a fatally flawed study was published is by itself not surprising or scandalous. Bad studies get published all the time in research across topics. What's far more important is what happens after a bad study is identified. And it's not just this study, there are other studies. Climate research has a unique problem in self-correction. And the COTS study is an example. It was only a few weeks after it was first published that the fatal flaws in the paper were identified. It took 18 months for Nature to retract the study. Of note, the authors were apparently given the opportunity to quote unquote correct their work. On the day that Nature published 2 devastating critiques, the authors of the study posted a brand new preprint that said they did a brand new analysis and never mind, forget the other paper, our answers stamp. So there was obviously some coordination between the journal and the authors. The other issue that's problematic with the COTS paper is that it was already incorporated by what's called the NGFS, the Network for Greening the Financial System, which is one of these newly created international organizations to bring climate scenarios to the global financial community. And the damage function of COTS et al. Was already incorporated in the NGFS. And now that the paper has been retracted, the NGFS simply put a note of concern on their website. And so for me, this underscores the dominant influence of climate scenarios and how we think about and talk about climate change. And obviously this study was fatally flawed. It was an outlier even in the economics literature. And according to a group called the Climate Brief, it was the second most cited study in all of 2024 of all climate research published around the world. So for me, it's an example of a deeper set of problems in climate research, where the more extreme the study, the more attention it gets, and the more difficult it is to correct the scientific record.
Do you have any personal opinion about the potential losses, income losses? They claimed it was 19% up till 2050. What is your estimate?
My estimate is that if you tell me what answer you want, I will find you the set of assumptions that will pass scientific scrutiny. The answer is, again, I very much view climate change as a risk management problem. There are plausible scenarios where there are large income losses in the future. Absolutely. There are also very plausible scenarios where there are marginal or positive benefits also. And anyone who tells you they have certainty, 19%, 5%, 23%, is being very selective in their reading of the economics and the science. The reason that we want to act on climate change is not because we know the future, it's because we don't know the future, and we want to take those risks off the table. So I'm not a big fan of predicting macroeconomic consequences of anything that far in the future. If I could, I'd probably be a lot wealthier man.
Okay, thanks a lot. Now we have a question from one of our audience, Dr. Björn Peters.
Hi, Roger. Very pleased to meet you. I'm a physicist by training, did statistical physics and time series analysis, read the entire third assessment report, and feel a little bit close to, but certainly not a specialist in climate science. And I was using your Substack on the low number of 2025 fatalities. In this way, I said, if after 50 years of global warming, we have the world is improving, it's I guess there is no climate crisis, and please and all the critiques that aggressed me for it, that please go and find where the issues are today. And so is this a misrepresentation, or so the argument that I feel somehow underneath is, and you mentioned it initially and just now again, well, we have risks, but after 50 years, I mean, shouldn't have these risks materialized in some way? And can we now blow off all the climate policies, or what's your scientific way of arguing?
Yeah, so I just put into the chat a new preprint that I and several colleagues have put together on exactly this topic. Part of and Bjorn, it's great to meet you as well. I'm a fan. I follow your work and your commentary.
I do.
So yeah. Let me say, part of the reason that this question is relevant is that advocates for climate action have for decades made the case that things are getting worse. And the fact is, whatever effects that human-caused climate change has had on outcomes that we care about, and we list many in this new paper, the fact of the matter is, objectively, most things we care about have improved, whether it's loss of life related to disasters, economic losses, agricultural productivity, you name it. And so arguing catastrophe related to climate change was always a bad idea. We should care about climate change not because it's an immediate or near-term catastrophe or making things worse, but because it poses unknowable risks about the future. And so I very much view decarbonizing the economy makes good sense only when the policies we put in place are in line with other goals we have: improving GDP, advancing energy access, cleaning up, the particulate pollution from coal, not relying on supply chain from nations that can't be trusted, which might include the United States these days. But whoever it happens to be, there are good reasons for that long-term trend of decarbonization to continue. At the same time, climate change does present some uncertainties into things we care about, like extreme weather and so on. Because they're not large today doesn't mean they may not be large in the future. But it turns out the policies we would put into place, let's say to reduce vulnerabilities to flooding or hurricanes, they make good sense regardless of your views on climate change. Yeah. So I don't view those trends as a reason not to pursue climate policy, but they do tell us, if you're trying to sell climate policy to normal people, telling them that the world is getting worse is probably the worst strategy you could have, because it is objectively false.
And by the way, so just one remark, sorry, Axel. Climate policy make the world much worse than climate change. So that's my concern, and I suggested a little bit more, but I don't want to monopolize now the attention.
Yeah, I mean, I would encourage everybody, have a look at our paper. That's the argument I make, because for some people, if you just say climate policy, it's like a magic force field, and it's by definition, it's a good thing. And we try to acknowledge there are smart and worthwhile climate policies, and there are bad climate policies, and we should be able to tell the difference. And our argument is let's focus on the smart climate policies, and not just assume that if someone puts a label climate policy, then automatically it must be virtuous and good, and you can't question it.
Wonderful. Thank you.
Okay. So the next one in line is Christian Wildmoser. You have to turn on your microphone, Christian.
Sorry, here I am. Roger, thanks very much for the presentation. Really great. My question is regarding the landscape of climate science in the United States. With the Trump organization's open hostility towards climate extremism, if I may call it that way, what do you detect? What is going on in the scientific climate science community in the United States? I mean, you got Chris Wright having this, asking those renegades, so to speak, Judith Curry, Roy Spencer, etc., writing this report for the Department of Energy on the consequences of climate change, which is very much in line with the stuff which you are presenting, and which I think we all agree with. The exiting of the Paris Agreement. Is funding drying up? Probably public funding for climate science is being reduced. So what's going on there? And what would you think would be the consequence also for future IPCC work? Because US scientists have always played a very large role in the IPCC. Also, on top of that, the United Nations, probably Guterres has lost tons of credibility. I mean, he probably is one of the most senior persons in policy with the least credibility you can think of around the globe. So what is your take on that? How will the debate evolve? Will it debate towards a more realistic framing? And we all know we won't be climate neutral in 2050. It's physically impossible, and people will not accept it anyway. So what is your take on that? Sorry, it's a very big.
It is, and for the next 2 hours, I'll be happy to.
For me, it's very relevant, and you are on the inside in the United States.
Yeah, so let me say a few things about the Trump administration. So first, maybe I'll start with Chris. I know Chris Wright. I knew Chris before he was Secretary of Energy. He's from Colorado. We've spoken many times. He's a super smart guy. He's thoughtful. He obviously understands energy in a way that really no former U.S. Secretary of Energy has understood it. At the same time, that effort that he put together, the climate working group with Judith Curry and others, was procedurally a disaster. They did not follow the rules, and have lost a court case. That said, they did interject, I think, some useful perspectives on science that haven't been present. I'm biased. I think our research is the most cited in their report, particularly our work on scenarios. Very interestingly, in all of the sound and fury that followed that report, and all the criticisms, no one chose to discuss any of our research that was cited in that report. Number one, it's because it's really good research. But I think a lot of the noise was to distract from the good research that was there. My understanding is later this week, the Trump administration is going to announce this is a technical term, but the rescinding of the EPA endangerment finding. And so under U.S. law, the administrator of the Environmental Protection Agency can find that certain pollutants endanger the public and regulations are necessary. It's a long history here, but carbon dioxide and other greenhouse gases fall under that law. And the U.S. Supreme Court ruled that carbon dioxide can be regulated. Long story short, the Trump administration is going to rescind or get rid of that endangerment finding later this week. There will be a lot of noise, a lot of howling, a lot of arguing. So let me just tell you, none of it means anything. This is symbolic politics, very characteristic of the Trump administration. The US Congress could clean all this up very quickly if they wanted to. There will be lawsuits, there will be a lot of newspaper articles. But let me explain, the Trump administration has lived under the endangerment finding for the first 4 years of Trump's first term and for the last year of Trump's second term, and it hasn't meant anything in terms of policy. And so the Trump administration, I would say they're not just against climate alarmism. I do think at the very highest levels, they are allergic to all things climate. And so, for example, they're talking about defunding NCAR, the National Center for Atmospheric Research, where I started my career here in Boulder. If it has the word climate associated with it, the Trump administration wants to cut it. And for me, as a matter of science policy, it's not particularly smart because climate is much more than just climate change. That said, the US Congress, which is responsible for writing checks for research, across the board this year has reversed all of Trump's proposed cuts, not just in climate, but in space exploration and medical research. And so this is typical of the US Congress in Trump's first term. It's important to understand that a lot of what the Trump administration does is short-term actions to generate headlines. They're not apparently interested in durable policy change. So I don't think NCAR is going to disappear. I don't think the bulk of climate research is going to disappear. I do think, and it is a bit of a puzzle because the reset on climate policy is not just a Trump phenomena in the United States. There's a broad-based discussion in places like Germany and Japan and elsewhere on more pragmatic approaches to energy and climate. So I do think it's much broader. One sign for me of the unseriousness of the Trump administration is the fact that it is not working with Congress. So under the US political system, if you want change to occur and to last for a period of time, it has to go through the US Congress. It is, in that sense, it's very much a parliamentary sort of system where the Congress has to act and the president has to sign into law. In the US, we have these things called executive orders. The president can tell the bureaucracy to do this or that, but it's very short term. The next president can undo everything he did. Joe Biden did many executive orders and the Trump administration got rid of them. It's not, it's not durable policy change. So I do think, so for example, I'll just end with a few other comments. The Trump administration has been trying to prop up coal energy in the US. They can't do it. They're going against forces of the economy that are just much stronger than what administrative action can do. And they're also trying to kill solar and wind projects that are well established, economically sound, already in development. So my view is, and this is not based on any inside knowledge, that Chris Wright is trying to implement pragmatic, sound energy policies under an umbrella of politics that is not particularly rational and much more black and white than energy policy deserves. All this is probably going to disappear on January 20th, 2029, when the next president comes in, and probably everything grinds to a halt later this year when the U.S. midterm elections occur. If the House in particular goes over to the Democrats, then basically there's nothing going to happen, no matter what press releases are put out.
Okay, thank you, Christian. Next one in line is Joachim Dengler.
Yeah, hello, Roger. I've been following your work for a couple of years already, and I've one time already also proposed you as a reviewer in one of my papers. Now I've 2 points I'd like to touch. You said in the beginning that that CO2 is not the only contributor to temperature changes. Yeah. Now, I would dearly kind of like to get a source or hear something about percentages. Yeah, can one say that? And I mean, for example, I some time ago, also the GISP2 data set, yeah, and we both know that the variability is much larger than the temperature changes in the last 170 years, yeah. And then another thing, let's take, for example, you said the agreed or the median sensitivity is 2.2, yeah. But the empirical sensitivity, if I just take the temperature like Hartkrut 4 or something like that, or it really doesn't even matter which data temperature set you take, you just get a sensitivity of 2. So so I'd like to hear how would you divide the natural influence towards the CO2 influence? And the other point is
can I address that one before you get to your second, just so I don't have to remember. Yeah. So I guess first, let me just make a small correction. That 2.2 degrees Celsius was the result of projections of climate models using the most plausible scenarios. It was not a measure of climate sensitivity. So whatever those models include as their assumption of climate sensitivity would be a different value than that 2.2. More generally, I'm a policy person. And so I recognize there are always valid debates about science, and they should carry on and continue. But from a policy perspective, let's just start with the IPCC. The IPCC argues that from today through the end of the 21st century, human-caused climate forcing, 80% of it will be due to emissions of carbon dioxide. Accept that or don't accept that. If you told me that instead of 80%, that number was 100%, or if you told me, no, instead of 80%, it's 20%, the policies that I would recommend would be insensitive to that degree of scientific uncertainty. In my view, there's simply no way to be certain that you can make the problem of carbon dioxide go away. The fact that carbon dioxide influences the climate in some way is sufficient for me to say, well, this multi-decade trend of decarbonization of the global economy, which has value beyond climate policy, is something that we should continue. Let me just tell you, if the world were to continue the historical rate of decarbonization of the global economy, we would hit net zero by the end of the century. And the warming would be less than 2.5 degrees Celsius. I can make a very good case for eliminating coal-fired energy globally for a lot of reasons. Climate impacts may be one aspect, but coal is pretty dirty. Countries that rely heavily on coal, like India and China, have expressed a desire to wean themselves to some degree off of coal for a lot of reasons. So the direction of travel in decarbonizing the economy, certainly we can justify that for many decades going forward. If we want to carry that forward further into the century, that's a decision that can be made after 2050 by my grandkids. So I'm not particularly concerned or interested in the finer debates about climate sensitivity, global temperature trends, the role of carbon dioxide, recognizing that it's a valid discussion. But again, from a policy perspective, I think it has much less relevance than some people believe. And let me say, here in the US, there are some people who say carbon dioxide is the only control knob that matters for the future of humanity. And there are some people who say carbon dioxide effects on climate, it's all a hoax. I think those two extreme positions are probably the ones I am least likely to support. There's a big fat middle area where we can acknowledge climate does change because of human influences, and all else equal, we'd probably like to not have those influences if we can do it in a way that's smart and benefits humanity in other ways.
Yeah, very good answer, Roger. Thank you very much. Joachim, I would like to ask you to place your second question later on, and now we have Heinz Otto Heidgen place his question. We'll come back to you, okay?
Roger, firstly, thank you very much for your excellent presentation. My question is more an epistemological question. We do not know how we got into this mess. Maybe you do, maybe you know. Apparently presenting facts, like the excellent facts that you have presented, is not doing the job. Not alone, at least. It seems that Western countries in particular are deeply into that mode of policy and that mode of direction for the energy transition. In all the discussions that you have had about public policy, and you are an expert on that, what is your view? What can we do? How can we become decent and realistic?
Yeah, this is a big one, and it's an excellent question. I do have some sense of how we got into this mess that climate policy has become. And part of it is, I mean, there's a long story here, but part of it is that, and it's not just me saying this, but with the end of the Cold War, around 1990, the West lost an overriding justification for its existence, which was to counter the Soviet Union. There was a unifying enemy. And with the fall of the Soviet Union, we also lost that big enemy. And there are people, politicians in the US and politicians in Europe, in the UK, who said, well, environmental sustainability is our new enemy. It's our collective, we are going to collectively battle against this enemy. There is also a history of catastrophism and apocalypse that had an earlier manifestation in global population concerns. The world was going to end because there was too many people. And that faded away as global crop production exceeded all expectations. Population growth did not explode in the directions that were expected. And the expert community was full of catastrophists looking for a new topic. I think another element was this idea that modernity, modern energy sources, technology was a bad thing. You just look at the reaction in Germany. It was at the forefront against nuclear power and the equation of nuclear power with nuclear weapons. Nein danke. It's in the US. I over the last few years, I had students in my class, 18 to 22-year-olds, who asked me almost in a quiet voice, "What's the problem with nuclear power again? It seems like it's perfect. It's safe. It provides incredible amounts of energy and has no carbon dioxide." And I do think that, particularly in the West and in green groups and environmental groups, there has been an anti-technology focus, and that these factors came together. For whatever reason, politicians have given the climate agenda more weight than it probably deserves from a democratic standpoint. The people who have been most focused on climate policy are elites, wealthy, highly educated people in Europe and North America If you ask most people what they care about when it comes to energy, they care about their electricity bill. They care about getting their kids to school. They care about reliable energy resources, much less about energy policies. And I guess the other thing I will say is in poor countries that have been developing rapidly, there has been almost an insatiable need for new sources of electricity and more broadly for energy. And when you have demands for more energy, it's much more difficult to argue for supply constraints or wind and solar over natural gas and nuclear. The United States has seen flat electricity demand for the last 15 years or so, and that's changing right now. Germany has seen falling electricity demand. So has the UK. And so it's very easy for elites in these countries to see these trends and think, well, we don't need it as much energy. We can switch it all to wind and solar. It's very easy to delude yourself. In the United States, I can tell you, Democrats in particular have decided that energy affordability is the most important thing now and are de-emphasizing talk of climate policy. And I think that's just a real world reflection of what citizens in democracies actually want. Last thing I'll say is Xi Jinping in China has said that China supports an energy transition, but they want to have the technologies in hand before they start turning things off. And I think the statements in the last few weeks by the German Chancellor about nuclear energy reveal the mistakes of turning things off before you have good replacements. And I do think that that's one reason why the wisdom is coming forward. So my view very much is how we get out of this mess is that we experts need to pay more attention to processes of democracy and what people want. I do think that the strategy of many people who have been called climate skeptics has been to focus on the science and to say, well, climate science isn't robust. Here's an alternative view of the science. No one cares about arcane scientific debates. What people care about are the realities of energy access, energy security, energy prices. And for some reason, politicians became convinced in Europe and the US that energy policy was a subset of climate policy. Climate policy was the big umbrella, energy policy was underneath. The reality that we're coming to appreciate worldwide is that energy policy is the big umbrella and climate policy is an important part of that, but it's just a little part of that. And so I think by focusing our discussions on energy policy and not climate science, we are far more likely to reach politicians and the people they serve where they already are. And I tell people, if you want, start with the IPCC Working Group 1. If you don't like it, argue about it. But that just gets you to the front door of the policy house. That doesn't take you inside. It doesn't tell you what you should do. It doesn't tell you if we should expand nuclear, reduce nuclear, expand wind, solar, whatever it happens to be. Energy is far more important to our collective futures than I think people have recognized in the last few decades, and that's changing now.
Okay, thank you very much. We have one final question from Karl-Heinz Frank. Is it correct, Karl-Heinz? Can you switch on?
Yes, it is. Yeah,
okay,
yes,
perfect.
Thank you, Roger, for that very good talk. I would like to come back to the Potsdam Institute. And as I understand, they are the promoters of the tipping points. What is your opinion about tipping points?
So tipping points, I think, is where people go when projections of catastrophe don't work. It's the sort of argument you make that, well, there are cliffs ahead and we may go off them. We don't know where they are. In one sense, I find those arguments very compelling. There are areas of ignorance and uncertainty in the future that we don't know about. So discussing those sort of things It's a little bit like a future pandemic or an asteroid impact or something that we just can't see over the horizon. So it's perfectly fine to discuss them, to debate them. However, the possibility of tipping points should not be used as the basis for making dumb policy choices today. So if the idea is, well, I said the word tipping points, therefore poor people can't develop using coal and natural gas, that doesn't make any sense to me. So yes, and there is an element of research from Johan Rockström and other fellow travelers that is very much catastrophist, very much focused on expert control of democratic institutions, that I just find objectionable to for a lot of reasons. But the idea that we have a small set of people who can uniquely see the future and therefore should dictate what we do. There was a former director of Pielke, Schellenhuber. He once promoted a cartoon that had him in it, and he was whispering in Barack Obama's ear, telling him what policies to implement. And I do think there is this image among some experts, particularly in the climate community, that democratic decision-making should give way to expert-led discussions. And I do see tipping points and other catastrophist arguments being put forward almost out of frustration that these dumb politicians and dumb citizens of the planet aren't listening to us experts. And I guess my view is we experts need to reconcile ourselves with democracy. They're not always going to do what we say, and that's okay.
Thank you very much.
Yeah, that was an excellent final statement, Roger. We very much appreciate that you took the time and present to us and discuss with us. It was a very interesting talk for all of us. Thank you very much for that.
Yeah, my pleasure. Great to see you all, and thanks for having me, and I really enjoyed the discussion.
Yes, and maybe
Thank you very much.
sometime in the next future we'll have another discussion, particularly if there's an interesting topic coming up, which we could
Anytime.
discuss.
All
Thank
right.
you very much, Roger. All the best, and
Have a good evening.
yes,
See
stay
you soon.
healthy, stay good.
Will we get the
Bye-bye.
slides?
I'm happy to send over the slides. I'll send them to Axel right
Yeah.
now.
Oh,
Okay,
thank you.
perfect.
Yeah.
Thank
All
you,
right.
Roger. Bye-bye.
Bye-bye.
Bye.
Thank you.
Wenn Ihnen unser Beitrag gefallen hat, abonnieren Sie doch einfach mit der Glocke unseren Kanal. Bleiben Sie auf den Laufenden zu allen Energie- und Klimathemen. Weitere spannende Videos finden Sie grundsätzlich auf unserem YouTube-Kanal. Auch unsere Homepage bietet viele interessante textliche Beiträge. Dort können Sie auch Mitglied in unserem Verein werden und/oder uns durch eine Spende unterstützen. Helfen Sie uns, auch zukünftig spannende Inhalte für Sie bereitzustellen. Wir freuen uns, wenn wir Sie beim nächsten Mal wieder bei uns begrüßen dürfen. Bis bald.